My research is about perception, how our perception as scientists influences our results, how an animal perceives and interacts with its environment, and how these two factors work together. So what has this got to do with coral reefs? Well, people living in many countries watering reefs rely on reef fish for much of their protein intake, so we want to find out what can increase the numbers of fish caught. Reefs are not flat surfaces. They're made up of an intricate bumpy structure full of holes. If you think of the holy shape of Swiss cheese, you've got a pretty good visual image. This elaborate reef structure provides shelter for fish, and in general, the more bumps and holes in the reef, the greater the abundance and biomass of fish. But this isn't always the case. Some studies have found no relationship between reef structure and fish populations. I'm interested in why that is. I propose that the scale at which we as scientists perceive and study the reef doesn't match the scale at which the fish we are studying perceive and interact with the reef. To illustrate, here's a land-based example. Mice and moose are both herbivores in the Rocky Mountains of North America. But despite both eating plants, they move and feed over very different areas. So if I measure the density of plants in a 1 by 1 metre patch, this may tell me about food availability for mice in the immediate area, but won't tell me anything about food availability for moose, which travel and feed over much wider areas. Similar issues arise when measuring the shape of the reef at one scale and assuming it relates to reef structure at all scales. I tested this on the reefs of the Seychelles, asking the question, is reef structure at one scale really representative of all scales? To do this, I used different sized measuring wheels of the sort you see marking lines on athletics grounds. On this reef, the large wheel doesn't fit into any of the holes, and so measures the distance between the start and end points as pretty much the straight line distance. Whereas the small wheel fits into all the holes, and so measures the surface as considerably longer than the straight line distance. Using this technique, I have shown that the structure of the reef is not the same across all scales. In fact, the reef is considerably rougher at the scales perceived by small fish. So what are the implications of this? Well, it explains differences in past research. A large parrotfish doesn't perceive and interact with the reef in the same way that a small butterfly fish does. So if I measure reef structure at the scale a parrotfish perceives, this will correspond to parrotfish numbers, but won't tell me anything about butterfly fish numbers. So if people rely on the catch of a specific species for food and income, and we want to know the influence of reef structure on this, we need to be measuring that structure at a fish-appropriate scale, and that depends on the individual species and their perception. In short, reef structure is in the eye of the beholder.